Hello everyone. Today we will presenting about license plate initial character analysis for vehicle categorizations. Here's our team member.
Hello. My name is Jacqueline Punon, who is the group leader. I'm taking responsibility to extracting the license plate from the video source.
My name is Pan Panyak Chare. I'm data collector and support in tech extractions and vehicle categorizations.
I'm Saranya Vijay Yotin. I'm responsible for character segmentation part.
I'm Wachapong Sengtong. I'm responsible to a part of tech recognition and car vehicle categorization.
So here is our presentations outline. And this is our key idea concept. Start with the first one, the license plate recognitions. Second one, character segmentations. And the third one is vehicle categorization. For license plate recognitions, we apply the CV2 for license plate recognitions. The key is to use the control to select the license plate and its position, then pick it out by using perspective transformations to transform it to the correct side plate. And we add the cropping image to determine the regions of interest, the filter for adjusting the video to control the noise and edge detections, and the threshold for controls. By appropriately adjusting values for threshold, kernels, and classifications criteria, we can locate the license plate on the car, even it moving. The locate license plate be extract and collect in folder for the next process.
And the second key concept is character segmentation. We utilize the EasyOCR library for character segmentation, a crucial step in text extraction from image. Utilizing deep learning models such as convolutional neural networks and recurrent neural networks, EasyOCR processes image containing Thai text to detect individual characters. The library segments character identifying boundaries and recognize specific characters. In the context of car license plate image captured from recognition system, EasyOCR accurately analyze and extract Thai text and numbers from license plates.
For the part of vehicle categorization, the vehicle categorization is the practice of classifying cars into the various groups. In this context, we use data from initial characters in license plates to classify vehicles. The method involves checking several characteristics on the license plates, such as the existence of specified symbols, numericals, or Thai language letters. This classification procedure can be beneficial for a variety of applications, including traffic management, automobile registration, and market research. Finally, it gave an organized approach to understanding and categorizing the many types of cars on the road.
And the next step is our process idea. First, we start with recording footage. In order to catch the car that crossed the university, we shoot video from the campus road. In this way, we make our attempts to reach a perspective that will enable us to obtain the license plate number of the car as clearly as possible. The second step, we extract the license plate. To extract the car license plate from the video, we process frame using OpenCV, enhancing and threshold each to identify potential license plate regions. Applying perspective transformation isolate these regions and display with overlay text and outline contours for visualization. Finally, the extract license plate image are saved. The third step is image processing. To identify the type of vehicle by scanning the license plate character, we read the text of the plate using ECOCR and creating lists in the XLSX file, and then apply an algorithm to filter the wrong data. And following that, we specify each starting character to classify the car. And the last step is record statistics. The final stage involves exporting the final data into Excel so that it may be examined further. This information includes the type of vehicle that traveled through the campus over a given period of time. Next slide, please. And here are examples of application usage. The first one is traffic analysis. Utilize license plate data to identify traffic patterns and peak hours, and optimizing traffic flow and transportation efficiency on campus. The second one is security monitoring. Integrate license plate recognition with security system to monitor vehicle movement, enhancing campus security and ensure compliance with regulation. The third one is parking management. Assess vehicle types passing through the campus to optimize parking allocation, improve availability, and implement tailored parking policy. And the last application is environmental impact assessment. Analyze vehicle types and frequency to assess environmental impact, guiding the implementation of sustainable transportation initiatives on campus.
Okay, for the CV technique, we have 7 of them. Next. For the first one, I'm choosing the feature extraction. It's just a simple one. We choosing the converting between the RGB to grayscale or the grayscale to RGB, and just use the average method that use all of the layer to divided by 3, and we're gonna get a grayscale. And the second technique, I'm choosing the ratio technique. By the type of the ratio technique I'm choosing is the binary, and I set the input to be 5. This is suitable enough to using with the control to extract the license plate. Next. And for the third one, I'm picking the cropping image. I'm choosing this to determine the region of interest. For reducing the noise, that's because the video we taking it from the road, we using the bird eye view, and is getting more area on the road more than the car and license plate that we want the most. So I select it and cutting it in the left and the right side to reduce the road from the frame. Okay, next. And the fourth one, I'm choosing the perspective technique. This method is the key there for this process. After we detecting the license plate, we're gonna get the position of them. I using this position value to using the perspective technique to cropping the license plate out, and choosing the ratio and determine the ratio of the real license plate to adjust the size to make it match with the real scale. Okay. Next. And the fifth one, the 2D kernel filter. This technique is make this algorithm to enable to detect the license plate because the control on itself cannot detect the license plate, I have to use the edge detection to chain it first before using ratio to make it more efficiency to use them with the controller. And after I detect the license plate, the output should be the real color one. So I use the sharpnet kernel to make it for better to identify by next process. Next. For the sixth, the control. Normally the console will detect all point that can make the boundary. So the control I adding the classification criteria to make it have the area, the ratio that I gonna get it from the height and the width of each controller, and I specify them to make it show us only for the real license plate. Okay, next. And the last one is the quite mainly one is the video capture. This video capture is one of is a class of the OpenCV library. Is used for video capturing from video file, image sequence, or cameras. It's very handy to tasking, avoiding video processing, computer visual, and real-time image analysis. This class will pick the video to take the process frame by frame. Okay, next. And the last one is the ECOCR. The ECOCR stands out for license plate detection due to its Python-friendly interface, robustness across diverse environments, and pre-trained models, schedules for variance language and font style, with its straightforward API. ECOCR simplify integration and offer efficient text recognition, making it a convenient choice for developers seeking simplicity, performance, and ease for use in license plate recognition.
Now move on to the flowchart of license plate recognitions. Here is the image of our flowchart. The flowchart starts by import CV2 and import numpy as NP. It begins by checking if the video file is successfully opened. If so, it's define kernel metrics and initialize constant necessary for filterings and processings. Within a loop that continues as long as the video is open, each frame is read from the video. If the frame is successfully read, algorithm process to extract the regions of interest, applying filter, convert the frame to grayscale, and perform thresholding to simplify further processings. Once thresholding is done, control are detected in the frames. If control are found, the algorithm iterates over them, calculating their areas and aspect ratio. If certain conditions are met, indicating the presence of license plate, the algorithm extracts the license plate regions, display, convert it to black and white, draw bounding box around license plate image, and display license plate to RGBs, and save the license plate image. If the loop continues until all contours are processed and the process frame is displayed, if a frame cannot to be read successfully, the loop will break. If the video file cannot be opened successfully at the beginnings, an error message is displayed.
A character segmentation flowchart. First, we start with import essential libraries and then create Excel file path and photo directory. And here we come with the decision. So if there is no image left in the photo directory, so it will combine all results into single data frame and save to Excel files, and then print data save to Excel. But if there is some image left in the photo directory, so it will go with the false one. It will read picture and convert color, and then use perspective transformation, which have original points and target points as a parameter. And then we use easy OCR to read Thai text, extract result in text and accuracy, and then print the result that it extract. And then it store results in variable.
So this is a part of a flowchart about the text recognition and categorization. So first we will show you about the define function, which have Thai language, Thai vowel, symbols, noun, text noun, sort group, Thai to ch, match ACCs, first th match, type. So these all will help about the filtering and sorting the categorize. So first about Thai language, it will check whether the license plate have Thai language or not. Thai vowel, it also check whether the license plate have the Thai vowel or not. Next about the symbol, check whether the data have the symbols or not, because normally the license plate don't have the symbols. About the noun, it will check does the data have a noun or not, because it should have, something like that. About the th noun, so generally the Thai license plate don't have the Thai text or don't have the Thai numbers, so this will check about Thai numbers whether it have or not. Sort group, it means sorting the data on the group. Like if you want to group by the last digit numbers like that, and you will sort it by its accuracy. Thai to th, it means checking the Thai character, because in the Thai lesson page should have only one or two letters on it. About the Mac ACC, it will return. It will show is this function due to let the data shows only the head of the group, or show only the first group after the sorting. Like it will show the max accuracy after it sort, something like that on the data. About the first th, this means checking and correcting the first Thai character on the text from license page. Match, it means checking the most common Thai letters. Like if you get some repeat data from the easy OCR, like if you get one, like if you get GOBO 1594, GOTO 1594, TOGO 1594, which it should be the same license plate, and it should be shows only one on the data. So this function will help you to group it by last four numbers, or the number after the text, and you can do other thing else. The car type, in this car categorization, I will use the car categorized by the first letter of Thai text on the license page. So for example, if the license page first Thai text is Gokkai, it will select as the sedan car, something like that. About the CNUM AF, it means counting the number after the Thai text and give it out. Like the number after the Thai text should have not more than 4, but it should have at least 1, something like that. It will return. about the num before text. This will check about the num before text. As you know, the Thai lesson page should have at least no, it should have most of it should have one or don't have the number before the Thai text. So this will check if it have or not, or if it have more than one, so that data cannot be used. About the grouping, this will help you for group the car which is if it have the license plate like repeatability. So this will help you to group by four numbers after the Thai text, something like that.
Okay, for the coding and result, this is the real code, and the first one is library important, and the second is create video capture, and the third is just for checking, and the last is the determine the variables. Okay, next. And this is okay, and this is the loop that we're gonna use in whole video. Start with the cropping, use the filter, taking ratio, and making the contour, and it has a for loop that gonna calculating every contour to finding the y and height, and getting the condition after this calculation to filter out the unused contour and display the contour that is gonna be license plate should be showing some value, and use the perspective transformation to let it out, and the last is saving it in the directory path. Next. And after that, we're gonna show all the frame, both back white and color one, and we have a condition if we that I press Q, it's gonna stop this process, and after that it's gonna be breaking the loop, and the procedure to closing this video capture class. Okay, that's all for the real code of the lesson based recognition. Next. And this is the result. Mostly is detecting the license plate quite well. And sometimes it might taking the other one that can boundary all around and has the matching ratio and area in some time, but mostly is quite well. Next.
And for the coding part for character segmentation, so like I have mentioned before in the flowchart, so first we create the Excel file name and also put it into the path, and for the directory we put the path that the file that we will use to process. And here is the coding steps. And for the output, so first we got output in the terminal like this, and then after that we convert into the Excel file like the right side, and that is the result from this coding part.
Okay, so here is a coding for the vehicle categorization. So we first input and set a file path and define the function that we will use in the filtering. Next. Next. So here is the main program. So we apply the our filters and set it set a part of output file and output the Excel file. Next, please. So here's our result. It will show about the file part which the photo came from, text on the license plate group. This is a group from the number after the type text, and next is the first type character and type of a car and the accuracy of the model.
For the discussion of this project, the first one is the photography composition. The license plate detection is typically deployed at the stationary points in the parking zones for close scrutiny of the place, which apply to flowing traffic routes. Vehicles are constantly moved to prevent obstruction from the other vehicles. We opt the bird's eye view to observe the rear vehicle, which provide the efficient except for the double-deck bus that fully obstruct the front vehicle. And the second one is the completeness of the license plate. The integrity of the license plate in the case where there are shadow or light falling on the license plate, causing the uniformity of the borders to be incomplete enough to use contour to identify the license plate. In many cases, causing the majority of the case to draw a line around the license plate letters or number until the size has been completed its entire cycle, so that the sign can be identified as continuous as possible. And the last one for my section is the validity of the license plate. Each car type has its own prefix, color, and board characteristic on the license plate, making the different black and white color separation impossible. The additional frame on some cars add to the diversity of sign appearance. Therefore, using alternative data source of the identification may not be feasible for this video set.
And the next discussion is, as of now, the code is unable to process and display results instantly. Video processing for license plate image collection and simultaneous easy OCR text scanning proved impractical due to overwhelming processing demands, resulting in compromised OCR accuracy and prolonged execution times. The next one is there are few easy OCR detection errors. Scanning license plate images yielded inaccuracies attributed to blurriness from video capture. Impacting text recognition, we address this by refining data selection for improved accuracy. And for the video captures, too many images on one plate. From plate display to illumination, the algorithm constantly records the frames, producing a large number of pictures and requiring a significant amount of processing time for each video. And the last one is problem in filter same digit number in final dataset. Although we can filter out some incorrect data, certain plates like 2 ขอ with number 4932, 4962, and 4982 remain unidentified by easy OCR, despite sharing identical plates. However, developing an algorithm to address this issue reveals similar numbers originating from different plates, such as 1 มข 1123 and 5 ขช 1143.
So next is about the proposed idea for improvement. So the video composition. So to achieve the most efficiency in the extracting the font from the license plate, we need to change the camera position so there is the less distance from the camera to license plates. This improvement will make the font extraction more reliable. So about the OCR model composition, we present utilize OCR to assist in the process of identifying the Thai character from a photo. However, we want to increase accuracy. We should look for another model that we would were better for our project and proceed more accurate results. Thank you.